Students will see the Nyquist stability criterion. So here we will take a simple feedback system, control system, and here you know that R of S is the input, C of S is the output, G of S is the forward gain, and H of S is the reverse path gain. So as you can see that the path gain is G of S into H of S. Okay, and here you can see that here it is plus, here it is minus. So the transfer function, as already I told, C of S by R of S is equal to G of S divided by 1 plus G of S into H of S. Now when you are equating the denominator to 0, that is the characteristic equation. So in the Nyquist stability criterion, the characteristic equation 1 plus G of S into H of S is equal to 0. That is assumed as Q of S. That the previous we analyzed the Q of S. Okay, that same we consider this characteristic equation as Q of S. Now the standard pole zero form of G of S into H of S. The loop gain is G of S into H of S. G of S into H of S, as already we come across, like gain into S plus Z1, S plus Z2, like that, S plus Zm divided by S plus P1, S plus P2, like that, S plus Pn. Here the number of Z represents the zeros, P represents poles. Now M gives the number of zeros, N gives the number of poles. So M, the number of zeros should be less than or equal to N. So this is your G of S. For example, G of S into H of S here. This is an example. Here K is 1, S into S plus 3 divided by S plus 4 into S plus 5. Here one 0 at 0, another 0 at S is equal to minus 3, one pole at S is equal to minus 4, and another pole at S is equal to minus 5. So two zeros and two poles. That hence it holds good. So here M should be less than or equal to N. Now Q of S is equal to 1 plus G of S into H of S. You have to make it. So Q of S is equal to 1 plus this term. Okay. Now when you are having 1 plus, here also you can see that when you are having 1 plus, what you will do? This will come to this side. You will take a general term, general denominator, that is S plus 4 into S plus 5. In the numerator, S plus 4 into S plus 5 plus S into S plus 3. The same way, this 1 plus this term, what happened is this denominator term will come as a part of the numerator term plus K into numerator divided by the common term, that is S plus P1, S plus P2. Now this is 1 plus G of S into H of S term. Okay, that is Q of S. And the zeros of Q of S. So this will be, as you can see here, in this example, you are getting like this. Then what you are doing is, you are cross multiplying it, multiplying these terms, and finally you are getting a term like 2s square plus 12s plus 20 divided by s plus 4 and s plus 5. So here it is a second order expression. There are two roots. There are two roots or a location of zeros that can be found by minus b plus or minus square root of b square minus 4ac divided by 2a. By using, you can find the, so after you are converting this form, the numerator term consisting of zeros. Okay, so that is why this entire term is, after multiplying it is modified into a term of s plus z1 dash, s plus z2 dash into s plus zn dash divided by the previous open loop G of S, H of S pole. That same pole you are getting as denominator. Now we observe that the zeros of q of s. Q of s is nothing but 1 plus g of s into h of s, not g of s into h of s. It is 1 plus. So here we observe that zeros of q of s at minus z raised to 1. So here it is s plus z raised z1 dash equal to 0 to find the 0. So s is at minus z1 dash, s is at minus z2 dash, s is at minus zn dash, like that are the roots of the characterization equation, and the poles of q of s. Poles of the q of s is at s is minus p1, s is minus p2, like that are the same as open loop poles of the system. So same pole. This is open loop function whose poles, that same pole you are getting as a closed loop or the characteristic equations pole are the same as the poles of the system. The system to be stable, for the systems to be stable, what is the condition? The roots of the characteristic equation, and hence the zeros of q of s must lie in the left half of s plane. So here, in order to a system to be stable, the roots of the characteristic equation, this is the roots, numerator, roots of the characteristic equation, and hence the zeros of q of s must lie in the left half of s plane. Even if some of the open loop poles lie in the right half of s plane, all the zeros of qs, i.e. the closed loop poles, must lie in the left half of s plane. So here zeros of q of s is nothing but closed loop poles. Okay, zeros of q of s. Q of s is we are taking as the denominator. This is you are considered as a q of s. And whose zeros means it is nothing but the closed loop poles may lie in the left half of s plane. This means that an open loop unstable system may lead to a closed loop stable operation. So what we can understand is, if some of the poles of the open loop system, here some of this is on the right hand side of s plane. So that means sometime s minus p2 means when you're equating 0, s is equal to p2. That is on right half of s plane. So some may the closed loop may, this means that open loop unstable system. So if some of the poles lies on the right half of s plane in an open loop, may lead to closed loop stable system. So when you are making like this 1 plus g of s and h s, and if you are cross multiplying, sometime it system may lead to a closed loop stable operations. Now, so here everything is very important, so you concentrate. In order to investigate the presence of any zeros of q of s, meaning whenever the zeros of q of s, you should understand that it is the closed loop poles, because already you know that this is the closed loop transfer functions. 1 plus g of s into h of s is nothing but q of s, that is the pole of the closed loop. Now this you are considering as a q of s, okay, and whose roots or this expression zeros is equal to the poles of the closed loop system. So here, in order to investigate the presence of any zeros of q of s 1 plus g of s h of s in the right half of s plane, That means zeros. That means closed loop poles are on the right half of S plane. Then you can see that it is not a stable system. So let us choose a contour which completely encloses the right half of S plane. Completely encloses the right half of S plane. So this is S plane. Here sigma, imaginary axis j omega, and a arc, or so we can see that a contour which completely encloses the right half of S plane. Now such a contour C. So this is known entirely, this contour is known as C. So it is starting from here, it will go like this, then coming like this, okay, and coming back, and it will come to the starting point. So such a contour is known as, such a contour C called the Nyquist contour, okay, is shown in figure. So this is the Nyquist contour. So what is the Nyquist contour characteristics? That we will analyze now. It is directed clockwise. So it is directed clockwise. See here, from here it will go like this, and it will come here, and it is coming and like this. So it is in this way. So it is a clockwise. It is directed clockwise and comprises of an infinite line segment C1. So this is an infinite line segment C1 along the j omega axis. So you can see along the j omega axis, the amplitude is plus j omega and here minus j omega. So C1 is an infinite line segment C1 along the j omega axis, and arc C2. This is an arc C2, of infinite radius. So radius R is tending to infinity, and its arc is represented by an expression R into e to the power of j pi. R into e to the power of j pi. So it comprising of a line segment on imaginary axis as well as an arc, okay, infinite line segment on j omega axis, and an arc of infinite radius, okay, and along C2 S is to R, where R tending to infinity e to the power of j pi, with the pi varying from, so here this pi is varying from, if you are taking from here, it is positive 0 to 90 degree, and if you are calculating in this direction 0 to minus 90 degree. So I can say that it is from plus pi by 2 to 0 to minus pi by 2. So here, as you can see that along C1, S is equal to j omega, and omega varying from minus infinity to plus infinity. Along C2, S is varying with R into e to the power of j pi, where R tending to infinity, with pi varying from plus pi by 2 to 0 to minus pi by 2. Now the Nyquist contour so defined encloses all the right half S plane zeros. Okay, so right half S plane Q of S plane zeros, and poles of Q of S 1 plus G of S into H of S. So if you are having a right hand side or right half of S plane containing poles or zeros, that all will be covered by this Nyquist contour. Encloses all the right half S plane zeros and poles of Q of S, that is 1 plus G of S into H of S. Let there be Z zeros. Okay, let there be Z zeros. Z zeros means we already come across in the previous section that there will be Z clockwise rotations, and each rotation is 2 pi, that is minus 2 pi. And p poles means it will have a p anti-clockwise rotation, and each rotation comprising of plus 2 pi. P poles. Okay, so let there be z zeros and p poles of q of s in the right half of S plane. As S moves along the Nyquist contour, in the S plane, a closed contour TQ is okay. So so here there are z zeros and p poles of q of s